All right, today we're going to add on to what we've been doing with a small twinge, okay? Here's the deal. What people have screwed up today isn't simplifying laws. What people have screwed up today are the rules of adding and subtracting with integers. Something you learned in 7th grade, something we reviewed at the beginning of the school year. So they're not screwing up new stuff, they're trying to go too quickly and end up making a mistake because today we have negative exponents. 2 rules we're learning today. The first one, any non-zero number to the 0 power, meaning like 3 to the 0, 5 to the 0, x to the 0, negative 762 to the 0 is always 1. Every single one of these, no matter if it's an exponent, or not, sorry, an exponent, a variable or a number base, if it's to the 0 power, it's 1. Second rule today, any non-zero number to a negative power is the multiplicative inverse of the power. Yeah, we got that, right? In other words, negative powers are the result of repeated division. In other words, a negative exponent causes you to need to move that base and the exponent to the opposite location in a fraction. Okay, so what does this mean for us, Miss Hoff? This first piece, write each expression using a positive exponent. Everybody agree with me, you can make any number or variable a fraction by putting it over 1. Agreed? So 6 to the negative third. If I put it over 1, I am just rewriting that number as a fraction. Okay, we cannot have a negative base or a negative exponent. So that exponent and base has to get drugged to the opposite location. Right now it's in the numerator, but it's negative and I can't have a negative. So I drag it to the denominator, and as soon as it crosses that fraction bar, the exponent becomes positive, leaving behind a 1. 6 to the negative third is actually 1 divided by 6 to the third. Repeated division because there's 3 6s. 6, 6, 6. So divide by 6, divide by 6, divide by 6. B, a to the negative fifth. Put it over 1. I can't have a negative exponent. So I'm going to take my base and my negative exponent. I drag it across that fraction bar. It goes to the bottom of the fraction and becomes a positive 5 exponent, leaving behind a 1. You guys now do C, D, E, and F. F, put a negative 7 exponent on F, on that P. All right, C, I have a negative exponent, so I really have it over 1. I can't have a negative exponent, so I pick that base up and I move it. What's my final answer? Very good. 1 divided by 7 to the second. D, who fell for it? 5 to the 0 is 1. Not 5 to the first, not 1 over 5, not anything. There is no exponent remaining. Anything to the 0 power is 1. E, m to the negative fourth. I can't have a negative exponent. I put it over 1. I drag my base down. My final answer, 1 divided by m to the fourth. F, I put it over 1. I can't have a negative exponent. I drag it down. My final answer, 1 divided by p to the 7th. Now, Dave Young said, is this seriously all we're doing? I think we could all agree if this is all we're doing, what a waste of our time. True story. Like if this is all you're going to have me do today, Miss Off, I'd rather not. That's not what you're doing today. It impacts it. It impacts it. Here's the deal, though. We're going to use the product of powers, meaning you're multiplying with exponents, and the quotient of power rules, dividing by exponents, what we learned last Wednesday and Thursday, to multiply and divide with negative exponents. The rules don't change. Keep the base. And when you multiply, you add the exponents. And when you divide, you subtract the exponents. Same rules as last week. The only difference is at the very end of your problem, your final answer should never have negative exponents. So when you're done multiplying and dividing or adding and subtracting, you stop and you look at it and you say, like, do I have negative exponents? If you do, you have to take care of them. If not, you're done. Here's the deal. People were like, ooh, I don't need to write this down. Because the other day, 2 plus 3 you could do in your head. 5 minus 4 you could do in your head, right? But now we're going to throw in negative numbers, and it throws in the integer rules. So write it down. G. Am I multiplying or dividing? What?
I was about to say times and I put it.
Okay. Multiplying. How do you know you're multiplying? The dot. Very good. Keep the base. What's your base?
5.
5. When you multiply, what do you do to your exponents? You add them. So write down 3 plus negative 5. Now think before you shout. I keep my base of 5. 3 plus negative 5 is negative 2. So here's the, and I use air quotes, new thing today. Can you leave that as your final answer? No, I can't have negative exponents. So I put it over 1. I take my base and my negative exponent. It needs to get drugged to the bottom. So my answer is actually, very good, 1 divided by 5 to the second power.
Wait, do we have to put that circle?
No. If you go from here to here, I'm totally good with that. Let's look at H. Multiplying or dividing? How do you know? Fraction bar, okay? Keep your base. What's your base? W. When you divide, what are you actually doing to your exponents? Subtracting. Take the top one first. What's your top one? Negative 1 minus negative 4. Here is the number one mistake that happened today. Everybody look at what I wrote compared to what you wrote. Do you have the same thing? You should. You're subtracting a negative. Now, when two negatives are right next to each other, subtracting a negative, what are you actually doing? Adding a positive. So really, I have negative 1 plus 4, which is positive or negative? Positive 3. Can I be done? How do you know? It's positive. We don't have to do anything to it. Newsflash. Not every problem is going to become a fraction. It depends if you end with a positive or a negative. Okay? You guys try I, J, K, and L. Finish the column and then do the one at the top. I, J, K, and L. What? You're subtracting a negative. You're really adding a positive. Multiplying or dividing? Multiplying. Keep your base. What's your base? 3. What are your exponents? And what are you going to do? Plus 2, which gives you 3 to the?
-6 power.
Can you leave that? Put it over 1. This guy gets dragged down. Your final answer. 1 over 3 to the 6th power. That's a very different thing. 3 to the 6th and 1 divided by 3 to the 6th. J, multiplying or dividing? Dividing. Keep your base. What's your base? 11. What are you doing to your exponents? Subtract. 2 minus 4 gives you -2. Austin. Can you leave this? No. Over 1. Your base and your negative exponent needs to go down. 1 divided by 11 to the 2nd. Okay, multiplying or dividing? Multiplying. When you multiply, what do? Add 9 plus -4. Positive or negative? Can I leave this? I can? Cool. L up at the top. Multiplying or dividing? Dividing. Keep your base, which is B. What do you do to your exponents? -4 minus -7. Subtracting a negative really means you are adding a positive. So you have B to the positive or negative? Can I leave it? Yes. Look at O. Look at O. How do you know you're multiplying, Grady? Very good. You have 2 parentheses right next to each other. It means I'm multiplying. How do I do this? Okay. Which is what? Distribute? Okay, what do you mean? Keep telling. Tell me what I should write down. I don't think so. Davian?
I don't know if I know, but I so 3, you know, and then I think parentheses, and then actually I forgot.
Eden?
Wait, do you do?
Calyx?
Alright, so you put 3 parentheses,
Oh yeah.
and then you put A1,
The only thing I would change on this, just so we get in the habit of, technically there's a 1 coefficient here, right? Now we have coefficients, so they need to be in their own parentheses. That 3 and that 1 are the numbers out front. So when those are our numbers out front, we actually multiply them. 3 times 1 is 3. Keep my base of A. What do I do to my exponents? Add them. 1 plus -3, which is -2. Can I circle that as my answer? Now, what is the issue with this? Why can't I circle it? It's a negative exponent. So the only thing we really have an issue with is the base A. 3 as the coefficient doesn't have a problem. Leave him alone. Only your base A is going to move. 3 is going to remain in the numerator. A to the 2nd goes to the denominator. You only move them if they're a negative exponent. You only move them if it's a negative exponent. Okay? I'm going to skip the other ones, flip it over. There's 2 that I didn't give you an example of that have been trouble today. So I'm going to give you 2 examples. 15 x to the 6th divided by negative 3 x to the 10th. 15 x to the 6th divided by negative 3 x to the 10th. Nolan. Okay, before we do that, you are correct. We are actually going to divide those. Let's separate them into two separate fractions here. 15 and negative 3 get their own fraction, and x to the 6th and x to the 10th. Because 15 and negative 3 are our coefficients, Nolan is right. We're actually going to divide those. What is 15 divided by negative 3? Negative 5. Now, to divide with powers, I keep my base. What's my base? X. What do I do to my exponents? Subtract 6 minus 10. So I end up with negative 5x to the negative 4th. Can I circle that? What do you have a problem with? The exponent is a negative. This guy right here. But 5's negative. But it's not an exponent. Nicely done, Nolan. It doesn't matter if the 5, the coefficient, is negative. We worry about the exponent. So negative 5 is going to stay in the numerator. X to the 4th goes to the denominator. Only move it if the exponent is negative. Only move it if the exponent is negative. Okay, one more. M to the 5th times n to the 3rd times m to the 4th times n to the negative 5th. Aiden, what you want to do? Very good. M's together and n's together. M to the 5th, m to the 4th, n to the 3rd, n to the negative 5th. Are we multiplying or dividing? Multiplying. So what do I do to my exponents? Add them. M 5 plus 4, n 3 plus negative 5 gives me an answer of m to the 9th, n to the negative 2nd. Can I be done? What do you hate? N to the negative 2nd. Do I care about m? No. Leave m alone. He can be there. M to the 9th is going to stay in the top. N to the 2nd moves to the bottom. Notice how my answer is one fraction. Your answer should be one fraction. Okay, set your pencils down and pay attention to me for 1 second. Reminder, tomorrow I'm going to be gone, yes? Okay, so when you come in, I'll have directions on the board. The first thing you're going to do is turn in your worksheet, if you don't get it done today, into that hand-in box. I'll be here after school, so I'll grab them after school. You guys are going to take notes on, I think it's 4 problems, so it's going to be like 5 minutes worth of notes. And I'll have a video for you to go through some things, and then it's an Alex assignment. So your work paper's in the back, like always. What do you have to score on Alex? 100%. Once you get 100%, if there's still time left in class, what are your options? Read, work on Alex, work on other homework, right? Can you sit and visit? No. Okay, I have been very lenient with you guys coming in. I know you're always hyped up after lunch, okay? I need your 100% focus tomorrow. You guys are a great group of kids. That's my very first line to my sub notes is, I have a great group of kids. They're really good for me. So I'm going to make a statement, and hopefully you agree. I will not come back to any concerns written down by a substitute, correct? I won't, because I know you're better than that. On Thursday, we'll have an exponent practice, scrambling everything. On Friday, you have a quiz. Cool? All right, you have a worksheet for homework. I will pass it out, and then I'll be around to correct it as you go. Here we go.